Welcome. Degree of unsaturation and index of hydrogen deficiency. IHD, like I said here, is the index of hydrogen deficiency. Now, under here we're talking about how to get the index of hydrogen deficiency. We have a beautiful formula here. The IDH is equals to 2N plus 2 minus H all over 2. At the course of this video, you will know how to use that formula to get the IDH. Let's go. Now, if you have, let me say this, you have this compound like this, and I ask you, what is the IDH of this compound? Please follow my series on Chem 132 under organic chemistry. If I write a condensed structure like this, you should know what it means. As you can see this structure, there is one thing you should know here. This is a single bond, so it belongs under the alkane family. As you can see, the IDH under the alkane family is 0. So the index of hydrogen deficiency, the IDH, is 0. Why? From here, if I should bring out this, you should know that this place has a carbon, here carbon, this junction a carbon, and a carbon. So that means we have 4 carbon in this structure. And you should know that this place, at this junction, we have, if you have a carbon here, so here we have how many hydrogen? We have 3 hydrogen at that terminal. So if there is a hydrogen here, we have a hydrogen at this terminal. So here is 1, 2. So we have a hydrogen here. We have another hydrogen here. Here we have. Good. Now, from here you can see we have a total of 3, 6, 7, 8, 9, 10. Right? So we have 10 hydrogen. And how many carbon do we have? We have 4 carbon and 10 hydrogen. Now, from here, I said I want you to calculate the IDH. So for you to calculate it from here, applying it to this formula, the N here is the number of carbon. The H here is the number of hydrogen. So from here right now, from this formula, I want to insert it here. So from here, CH4, H10, C4H10. I want to apply to this formula. So from here, what I have is, we have 2 times, how many carbon? 4, right? Plus 2. Now, minus, how many number of hydrogen? 10. Divided by 2. Now, 2 times 4 will give you 8. Plus 2 minus 10 divided by 2. And so this will give you 10 minus 10 divided by 2. And so your answer here is 0. So I said, in calculating the index of hydrogen deficiency, if we are talking about single bond, do not waste your time. The IDH, the answer is 0. That's why I'm taking my time to do this. At the course of this video, I will teach you how to calculate the IDH for single bond, double bond, triple bond, and then we're going to go ahead to solve more complicated questions. Follow me. Now, you can see from the board that the answer is 0. Now, what will happen right now, if I should turn this place, I have a compound like this same compound, and I add a bond here. That means it has a double bond. Now, what will now be the IDH? Now, automatically, the IDH for a double bond is 1. And of course, if you still want to prove it from this place, using the formula I've written for you, this is C4H8. Remember double bond, so a carbon will go, so this is C4H8. I don't want to start teaching condensed formula. This is not what I'm here for. But like I said, this is 3, here is 2. Now, you can see we have 1, 2, 3, 4. So 1 hydrogen will be here. This is 1, 2, 3, 4. Now at this terminal we have 1, 2. That means you have 2 hydrogen rather than 3. And if you count it, this is 5, 6, 7, 8. So that is how I got C4H8. Now, if it is in triple bond, you have something like this. You see, this is a process of double bond. Immediately you see this, the IDH is automatically 1. But if you want me to prove it, this is C4H8. Now if I put it into this my formula, the IDH, which is 2N plus 2 minus the number of hydrogen, which is H, divided by 2. Now my N here is 4. So we have 2 bracket 4 plus 2 minus the number of hydrogen here is 8. Now divided by 2. Now 2 times 4 will give you 8 plus 2 minus 8 divided by 2. So I am left with 10 minus 8 divided by 2. And this is 2 all over 2, which will give me 1. From here you can see that when I'm talking about the double bond, that the IDH is 1. And I just proved it here. I am taking my time because there will be a time I will write a very big structure. And if you do not understand this method I'm doing, you cannot understand how I got the answer. And believe me, I'm not going to waste time when I come there. Let's go to the next example. Now, from the board, I'm taking my time. What about when we're talking about the triple bond? If we're talking about the triple bond, how are we going to get it? Now, what if we have a triple bond from the bond? If I have this is a triple bond, now of course this is the hydrogens, these are the hydrogens. Now, of course, the IDH for a triple bond is equals to 2. And if you want to prove it, this is C4H6. Applying in our formula H2M plus 2 minus number of hydrogen all over 2. And this will give you 2 times 4 plus 2 minus 6. And you divide everything by 2. So you have 8 plus 2 minus 6 divided by 2. So this will give you 10 minus 6 divided by 2, which will give you 4 divided by 2, which will give you 2. So, at the course of this video, I said the IDH for a single bond is 0, for a double bond is 1, for a triple bond the IDH is 2. Now, what about if it is a ring? Now, if it is a ring, you can see it at the board. Now, from this cyclobutane, you can see it have two hydrogen because this is 1, 2, 3, 4 here. So you have two hydrogen here. And if it is a benzene ring, this should give you C4H8. And whenever we are talking about the ring, the IDH or the IHD, not ID, I'm calling IDH since, the IHD, which is the index of hydrogen deficiency, is just 1. So what we're talking about ring, the IHD is equals to 1. Please. Now, if the IHD is 1, please can you apply it into this formula and know if you can get the answer? Of course, if we do, we should get the answer. Apply it yourself and get the answer. Now, let me go to another example. What if you have a compound like this? So you have this compound. You have CH3. You have C, triple bond C, and you have CH3. And I ask you, what's the IDH? So from here, can you pause the video and get the answer? Yes, of course. The total number of carbon here is 1, 2, 3, 4. So this is 4 carbon. Hydrogen is 6. H6. So you can get the answer. So all you need to do is just put it into this formula and get your answer. And let me do it. Let me take my time. Now this is 2 brackets 4 plus 2 minus 6. You divide everything by 2. This time this will give you 8 plus 2 minus 6 divided by 2. And this will give you 10 minus 6 divided by 2. This will give you 4 divided by 2, which is 2. So the IHD is equal to 2. Now, let's go ahead. Now, let me make it more interesting. What if you have a compound like this? You have this compound. So you have 1, 2, 3. Now, if I ask you to calculate the IDH here, how are you going to calculate it? Now, if I look at this compound immediately, the IDH is 3. Why is this? Please, I'm calling IDH, I'm calling IHD. The most important thing is for you to understand it. So I think I prefer the IDH than the IHD. I'm talking about the index of hydrogen deficiency. So from here, whenever you see double bond, of course the IHD is 1, 1, 1. So the total number is what? 3 immediately. If you still do it by this normal method, you still get the answer. So please learn the easier method. You get 1. Now, what if I have something like this? I have triple bond here, and let me put double bond here. So I have double bond here, and I have double bond here. The IHD here, of course, this is 2. This is 2, and this is 2. So automatically the IHD is equals to 6. Now, what if I have something like this? Then I have triple bond here, and I have double bond here. Now, what is the answer? That's why I'm saying that all you need to do is not have to play with this. From here, if I have this compound, you can see here that here is 2 and here is 1. So automatically the answer, the IHD, is 3. Can you see how easy this is? This is so easy. Now let's continue and go to other ones. Now we have a 1 here based on benzene ring, and I asked you to calculate the IHD. You can see from here that we talked about from my introduction. I said whenever we're talking about a ring itself, the IHD is what? 1. Now look at this place. We have a double bond here, double bond here, double bond here. So the shorthand method is, because it's a ring, it has 1 plus it has double bond here, double bond here, double bond here. And we say whenever there is a double bond, we give it a IHD of 1. So here is 1, 1, 1. So the total number of bond here is 3. So the answer here is 4. So the IHD is 4 immediately. If you want to use the formula, benzene is C6H6. So this is 2M plus 2 minus H all over 2. So this is 2 divided plus 2 minus 6 all over 2. You have 12 plus 2 minus 6 all over 2. So this will give you 14 minus 6 divided all over 2. And this minus this will give you 8. You divide it by 2, what you get is 4. So please learn the shorter method and learn the other one. You get why. Now let's proceed. We have a beautiful compound here at the board. Now let me make it more interesting and put a double bond here. Now using the shorter method, and I have to calculate the IHD of the compound above. All you have to do is look at it. Like I said, pause the video and know if you can do it yourself immediately, please. The ring itself is 1. We have the 2 double bond here, and the 2 double bond here is the 2 double bond here will give us 1 plus 1. So we have 2 here, and then you have here we have triple bond here. So this is 2. So plus 2, this will give you 5. So the IHD is 5. Now remember, I'm just forming this thing on my head because if you look at it, this is 1, 2, 3, 4. So, and it has a bond here. So if you want to, you can still use the number 1 and get it. Now, let me give you a simple class one. What if I clean this double bond here and ask you what is the IDH? Can you get it? Can you get it? Now from here, it's still the same thing. If you want to calculate it, this is still C7H8. You can still get it. Now here, the ring is 1. Now it has a double bond here, that means plus 1 again. So it's 1. The double bond here is also 1. Now here we have triple bond, which is what? 2. And that will give you what? The total number 3, 4. So here is 4. If you use this same formula, you should also get 4 as the IHD. Let's go to more interesting calculations. Now you have this example at the board and you have to calculate the IHD. Now using the formula, here is a ring, so you have 1. we have a double bond here. So double bond plus 1, another double bond plus 1, another double bond plus 1. Here is triple bond. So the IHD for triple bond is 2. Here is double bond plus 1. Here is triple bond. So we have plus 2. Here we have 1, 2, 3. And plus the ring. So plus 4. So this place is 4 plus 2 plus 1 plus 2 plus 4. So we have 8, 10, 13. So the total IDH this place is 13. You see it? So if you don't learn the shortest formula to get this is my method I'm using. If you see this in the examination hall, before you finish writing here, you come here and write C8, AC, and finish counting all these things, time don't pass. Learn this method, you get wow.